Tonight, we will listen to a very slow science lecture about the universe. Nothing exciting will happen here. Just calm thoughts, slow explanations, and quiet space. So you can relax, and slowly drift into sleep. Scientists believe the universe began around 13.8 billion years ago. This event is known as the Big Bang. Despite the dramatic name, it was not actually an explosion. Tonight, we begin a very slow and quiet science lecture about the universe. There is nothing dramatic here. No sudden events. No exciting discoveries happening right now. Just calm ideas. Slow explanations. And a gentle journey through space. The universe is everything that exists. It includes space, time, stars, planets, galaxies, and even the smallest particles of matter. Everything you see around you. The ground beneath your feet. The air you breathe. The light from the sun. All of it is part of the universe. Scientists believe the universe began about 13.8 billion years ago in an event known as the Big Bang. Despite its dramatic name, the Big Bang was not exactly an explosion. Instead, it was the beginning of space itself. Before that moment, there were no stars, no planets, no galaxies, and perhaps not even time as we understand it. Everything that would ever exist was compressed into an extremely small and incredibly hot state. Then, slowly, space began to expand. Not like a bomb exploding outward, but more like a balloon gently inflating. As space expanded, matter spread out. Tiny particles formed. These particles slowly combined into atoms. Atoms gathered into clouds of gas. And over millions of years, those clouds began to collapse under gravity. From those collapsing clouds, the first stars were born. Stars began to shine. Light appeared in the universe. And slowly, the dark, empty universe began to fill with glowing points of light. These stars were not alone. They gathered together in enormous groups called galaxy. A galaxy is a massive collection of stars, gas, dust, and dark matter, all held together by gravity. Some galaxies contain millions of stars. Others contain billions, or even trillions. One of those galaxies is our home. It is called the Milky Way. The Milky Way is enormous. It stretches about 100,000 light-years across. Inside it are hundreds of billions of stars. One of those stars is our sun. And around that sun, slowly orbiting through space, are the planets of our solar system, including Earth. Our small, quiet, blue planet. From here, looking up at the night sky, the universe can feel calm and peaceful. But it is also unimaginably large. So large, that even light, the fastest thing in the universe, takes years to travel between stars. Light moves at about 300,000 kilometers per second. That is incredibly fast. And yet, even at that speed, the nearest star to Earth, after the Sun, is more than 4 years away. Scientists measure these enormous distances using something called a light year. A light year is the distance that light travels in 1 year. That distance is about 9.46 trillion kilometers. Numbers like this are difficult for the human mind to imagine. Because the universe is not just big. It is unbelievably vast. When astronomers look through powerful telescopes, they do not just see stars. They see entire galaxies. And when they look deeper into space, they discover that there are not just hundreds, or thousands, or even millions of galaxies. There are billions of galaxies. Possibly even trillions. Each galaxy containing billions of stars. Each star potentially surrounded by planets. And some of those planets, somewhere, far away, may even have oceans, atmospheres, and quiet worlds of their own. But the universe is not only made of stars and planets. Much of it is empty space. Vast regions where almost nothing exists. Cold, silent, and dark. Yet even in this emptiness, gravity is always working. Slowly pulling matter together. Forming stars. Building galaxies. Shaping the structure of the universe. Over billions of years, the universe has continued to expand. Galaxies drift slowly apart from each other. Space itself stretches quietly. And the universe grows larger and larger. All of this happens very slowly. On timescales far longer than a human life. Stars are born. They shine for billions of years. And eventually they fade away. But new stars continue to form. New galaxies evolve. And the universe continues its quiet journey through time. When we look up at the night sky, we are not just seeing the present. We are also seeing the past. Because light takes time to travel. Some of the stars we see tonight sent their light toward Earth hundreds, or thousands, or even millions of years ago. In a way, every time we look into space, we are also looking back through time. The deeper we look, the further into the past we see. And far away, at the edges of the observable universe, astronomers can see light that began its journey billions of years ago. Not long after the universe first formed. It is quiet to think about. That the universe has existed for billions of years. And will likely continue for billions more. Our planet. Our lives. Our moments of wakefulness and sleep. Are just tiny pieces of that enormous story. And yet, here we are. On a small planet. Inside a quiet corner of the Milky Way. Listening to a slow lecture about the universe. Nothing urgent. Nothing demanding. Just the calm idea. That above us. Beyond the clouds. Beyond the atmosphere. Beyond the orbit of the moon. There is a vast universe. Filled with stars. Galaxies. And endless space. And as the universe continues its slow expansion, your mind can also begin to slow down. Thoughts becoming quieter. Breathing becoming softer. Just like the calm, silent space between the stars. Now, the universe is filled with many things. Galaxies, planets, dust, and quiet empty space. But one of the most important objects in the universe is the star. Stars are the glowing lights that fill the night sky. On a clear night, far from city lights, you can look up and see hundreds of them. Some appear bright. Others appear faint and distant. But almost every point of light you see in the night sky is a star. One of those stars is very familiar to us. It is the sun. The sun is the closest star to Earth. It provides light, warmth, and the energy that supports life on our planet. Without the sun, Earth would be a cold and dark world. But even though the sun looks very large in our sky, it is actually just an average star. There are stars in the universe that are much bigger, and much brighter. Some stars are hundreds of times larger than the sun. Others are smaller and dimmer. Yet all stars share something in common. They are giant spheres of extremely hot gas. Mostly made of hydrogen and helium. Inside every star, something incredible is happening. Deep in the center, the temperature becomes unbelievably high. Millions of degrees. At these temperatures, hydrogen atoms collide and combine. This process is called nuclear fusion. During nuclear fusion, hydrogen atoms join together to form helium. When this happens, a small amount of mass is converted into energy. That energy escapes from the star as light and heat. This is why stars shine. They are constantly producing energy deep inside their cores. This energy slowly travels outward through the layers of the star. until it finally escapes into space as light. Some of that light travels millions, or even billions, of years. Eventually, a tiny fraction of it reaches Earth. And when it does, we see a star shining in the sky. But stars were not always there. At the beginning of the universe, there were no stars at all. Stars formed slowly, over time. They begin their lives inside enormous clouds of gas and dust called nebula. These clouds drift quietly through space. Sometimes they stretch across hundreds of light years. Inside these clouds, gravity slowly begins to pull gas particles closer together. At first, the movement is extremely slow. Almost unnoticeable. But over millions of years, gravity gathers more and more gas into a dense region. As more gas collects, pressure increases. Temperature rises. The center of the cloud becomes hotter and hotter. Eventually, it becomes hot enough for nuclear fusion to begin. At that moment, a new star is born. The star begins to shine. And light spreads into the surrounding space. This early stage of a star's life is called a protostar. Over time, the star stabilizes. Gravity pulls inward, while the energy from fusion pushes outward. When these two forces balance each other, the star enters the longest stage of its life. This stage is called the main sequence star. Most stars spend billions of years in this stable stage. Our Sun is currently in this phase. It has already been shining for about 4.6 billion years. And scientists believe it will continue shining for another 5 billion years. During this time, the Sun steadily converts hydrogen into helium, slowly releasing energy that reaches Earth as sunlight. But stars do not live forever. Eventually, the hydrogen in the core begins to run out. When that happens, the balance inside the star changes. Gravity starts to pull the star inward again. The core becomes hotter. And the outer layers begin to expand. At this stage, the star becomes what astronomers call a red giant. A red giant is much larger than the star once was. Some red giants grow so large that they could swallow nearby planets. But even this stage does not last forever. Eventually, the star reaches the end of its life. What happens next depends on the size of the star. Small and medium stars, like our Sun, end their lives quietly. They shed their outer layers into space. These glowing clouds drift away slowly, leaving behind a small, dense core. That core becomes a white dwarf. White dwarfs are incredibly dense. A piece of white dwarf material the size of a teaspoon would weigh tons. But they no longer produce energy through fusion. They slowly cool down over billions of years. Large stars, however, have a much more dramatic ending. When a massive star runs out of fuel, the core collapses suddenly. Then, in a fraction of a second, the star explodes. This enormous explosion is called a supernova. A supernova can briefly shine brighter than an entire galaxy. It releases enormous amounts of energy. And it spreads heavy elements across space. In fact, many of the elements found on Earth, like iron, gold, and calcium, were created inside ancient stars that exploded billions of years ago. In a very real sense, the atoms inside your body were once part of distant stars. Stars that lived, burned brightly, and ended their lives long before Earth existed. This is why scientists sometimes say, "We are made of star dust." Every star in the sky has its own story. Some are young. Some are ancient. Some are quietly shining. Others are preparing for their final moments. Yet from Earth, they appear calm and steady. Tiny points of light, scattered across the night sky. And when you look at them, it is easy to forget how powerful they truly are. Each star is a giant nuclear furnace, producing energy on a scale far beyond anything humans can create. Yet from our distant viewpoint, they appear gentle and peaceful. Small lights in the darkness, and as we continue this slow science lecture, we will move even further through space. Beyond stars. Beyond planets. Into deeper mysteries of the universe. But for now, just imagine the quiet glow of countless stars spread across the vast universe. Billions of them, shining silently. For millions, or billions, of years, now, we continue our slow and gentle journey through the universe. In part 1, we spoke about the beginning of everything. Now, we focus on the quiet lights that fill the darkness. Stars. When you look at the night sky, the tiny points of light seem peaceful. Still. Almost unmoving. But each one is a massive sphere of glowing gas. Burning slowly, for millions or billions of years. The closest star to us is the sun. It feels warm on your skin during the day. It rises, it sets, and it repeats this pattern calmly. But inside the sun, powerful processes are taking place. Deep in its core, temperatures reach about 15 million degrees Celsius. At that temperature, hydrogen atoms move extremely fast. They collide. And when they collide with enough force, they join together. This process is called nuclear fusion. Fusion turns hydrogen into helium. And in that transformation, energy is released. That energy slowly travels outward, layer by layer, until it escapes into space as sunlight. The sunlight that reaches Earth left the sun about 8 minutes earlier. It traveled across 150 million kilometers of space. Silently. Without sound. Without effort. Just light moving through emptiness. But not all stars are like the sun. Some are smaller. Some are much larger. Some are cooler and glow red. Others are hotter and shine blue. The color of a star depends on its surface temperature. Cooler stars appear red. Hotter stars appear white or blue. One of the brightest stars visible from Earth is Sirius. It shines brightly in the night sky, yet even Sirius is just one star among billions in our galaxy. Stars are born in cold regions of space known as nebula. These clouds of gas and dust drift quietly between stars. Inside a nebula, gravity slowly pulls particles together. This process can take millions of years. Very slow. Very steady. As the gas becomes denser, it forms a growing ball of matter. This early object is called a protostar. It is not yet a true star. It does not yet produce energy through fusion. But it continues gathering mass. Slowly heating up. And when the core temperature becomes high enough, fusion begins. A star is born. For most of its life, a star remains stable. Gravity pulls inward. Fusion pushes outward. When these forces balance, the star enters what scientists call the main sequence star stage. Our Sun is currently in this stage. It has been stable for billions of years. And it will continue this calm balance for billions more. But nothing in the universe lasts forever. Eventually, the hydrogen fuel in the core begins to decrease. The balance shifts. Gravity becomes stronger. The core contracts. And the outer layers expand. The star grows larger. Cooler on the surface. Red in color. This phase is called a red giant. When the Sun becomes a red giant, billions of years from now, it may expand so much that it engulfs Mercury. Possibly even Venus. Earth's future at that time remains uncertain. But this event is so far away, that it is nothing to worry about tonight. For larger stars, the ending is more dramatic. Massive stars burn their fuel quickly, they live fast, and die young. When their cores collapse, they explode in a brilliant event called a supernova. A supernova releases more energy in seconds than our Sun will produce in its entire lifetime. For a short time, it can outshine an entire galaxy. After the explosion, what remains depends on the mass of the original star. Some leave behind an extremely dense core called a neutron star. Neutron stars are incredibly small. Only about 20 kilometers wide. Yet they contain more mass than the Sun. A single teaspoon of neutron star material would weigh billions of tons. If the original star was even more massive. The collapse continues, gravity becomes so strong that not even light can escape. This forms a black hole. Black holes are not cosmic vacuum cleaners. They do not roam around swallowing everything. They simply sit in space. With gravity so strong that anything too close cannot escape. But most stars in the universe live quietly. They shine steadily. They fuse hydrogen. They glow softly across the vast darkness. And over billions of years, they slowly change. What makes this beautiful and calming is the timescale. Stars evolve over millions or billions of years. Nothing happens quickly. Nothing sudden from our perspective. The star you see tonight will likely look the same tomorrow. And next year. And long after we are gone. The light from distant stars takes years to reach us. When you look up at the sky, you are seeing ancient light. A message sent long ago. Traveling silently across space. In fact, the iron in your blood. The calcium in your bones. The oxygen you breathe. Were all formed inside stars. Heavy elements are created in the intense heat of stellar cores. Or during supernova explosions. Long before Earth formed. Ancient stars lived and died. Spreading these elements into space. Eventually, gravity gathered that material again. Forming new stars. New planets. And one small planet, called Earth. So in a quiet and poetic way, you are connected to the stars. Not just by sight, but by substance. And as you listen to this slow lecture, imagine billions of stars across the universe. Some blue. Some red. Some young. Some ancient. All shining quietly. All part of the vast and expanding universe. And just like the stars maintain balance. Gravity pulling inward. Energy pushing outward, your body can also find balance tonight. Breathing in. Breathing out. Slow. Steady. Calm. Now, after talking about stars, we move a little closer to home. Around many stars in the universe, there are objects slowly traveling through space. These objects are called planets. A planet is a large body that moves in an orbit around a star. Unlike stars, planets do not produce their own light. Instead, they reflect the light from the star they orbit. In our cosmic neighborhood, all the planets move around one central star. That star is the Sun. The collection of the Sun, planets, moons, and other objects is called the solar system. The solar system formed about 4.6 billion years ago. It began as a giant cloud of gas and dust drifting through space. Over time, gravity slowly pulled that material together. The center became dense and hot. Eventually, nuclear fusion began. And the Sun was born. But not all of the gas and dust became part of the Sun. Some of it remained in a large spinning disk around the young star. Inside this disk, small particles began to collide. They stuck together, forming larger pieces. These pieces continued to grow. From dust, to rocks, to mountain-sized objects. Over millions of years, these objects grew larger and larger. Eventually they formed planets. In our solar system, there are 8 major planets. The closest planet to the Sun is Mercury. Mercury is a small rocky world. It has almost no atmosphere. During the day, its surface becomes extremely hot. At night, it becomes very cold. Next comes Venus. Venus is similar in size to Earth. But its atmosphere is very thick. It traps heat through a strong greenhouse effect. Because of this, Venus is actually the hottest planet in the solar system. After Venus comes our home planet, Earth. Earth is special because it has liquid water on its surface. It has a protective atmosphere. And it supports life. From space, Earth appears blue and white. Clouds slowly move across its surface. Oceans reflect sunlight. And the planet rotates quietly once every 24 hours. Traveling farther from the Sun, we reach Mars. Mars is often called the red planet. Its surface contains iron oxide, which gives it a reddish color. Mars is colder than Earth. But scientists believe that billions of years ago, it may have had rivers, lakes, and possibly oceans. Beyond Mars, the solar system changes. The next planets are much larger. They are called gas giants. The first is Jupiter. Jupiter is enormous. It is more than twice as massive as all the other planets combined. Instead of a solid surface, Jupiter is made mostly of gas. It has powerful storms. One of them, known as the Great Red Spot, has been active for hundreds of years. Next comes Saturn. Saturn is famous for its beautiful rings. These rings are made of ice and rock particles. They orbit the planet like countless tiny moons. Saturn is also a gas giant, with many moons of its own. Further away, we reach Uranus. Uranus is unusual. It rotates on its side. Instead of spinning upright like Earth, it appears to roll along its orbit. This gives Uranus very unusual seasons. Some parts of the planet experience decades of daylight, followed by decades of darkness. Finally, we reach the most distant major planet, Neptune. Neptune is a cold and windy world. Despite being far from the Sun, it has some of the fastest winds in the solar system. Storms move through its atmosphere at incredible speeds. Beyond Neptune, the solar system becomes more sparse. There are icy objects, dwarf planets, and distant debris fields. One of the most famous dwarf planets is Pluto. Pluto was once considered the ninth planet. But scientists later reclassified it as a dwarf planet. Even so, it remains one of the most fascinating worlds in our cosmic neighborhood. The solar system is not quiet in the sense of being empty. Many objects move slowly through it. Asteroids drift between Mars and Jupiter. Comets travel long elliptical paths around the Sun. Moons orbit their planets. And all of these objects move according to the laws of gravity. One of the most important scientists who helped explain planetary motion was Isaac Newton. Newton described gravity as a force that attracts objects toward each other. The larger the mass, the stronger the gravitational pull. This is why planets remain in orbit around the Sun. They are constantly moving forward through space. But gravity gently pulls them inward. The result is a stable orbit. A delicate balance, repeating endlessly. Each planet follows its path year after year. Quietly. Predictably. Calmly. And when we look at the night sky, we are not only seeing distant stars. Sometimes we are seeing planets too. They appear as bright steady lights, moving slowly across the sky over weeks and months. From our small planet, inside this vast solar system, it can feel peaceful to remember how everything moves in harmony. The planets orbit the Sun. Moons orbit planets. And the entire solar system travels through the galaxy. Slowly. Silently. Without rush. Without noise. Just the quiet motion of celestial bodies, drifting through the universe. And as we continue our slow journey through space, the next part of our lecture will explore one of the most mysterious objects in the cosmos. Black holes. Regions where gravity becomes so strong that even light cannot escape. But for now, just imagine the calm movement of the planets, circling their star, in the quiet darkness of space. Now, we move deeper into one of the most mysterious topics in the universe. Black holes. They sound dramatic, powerful, almost frightening. But in reality, black holes are simply objects where gravity has become extremely strong. So strong, that even light cannot escape. To understand black holes, we must first think about gravity. Gravity is the force that pulls objects toward each other. It is the reason planets orbit stars. It is the reason the moon orbits Earth. And it is the reason you remain standing on the surface of our planet. One of the scientists who helped explain gravity was Isaac Newton. Newton described gravity as a force between masses. The larger an object is, the stronger its gravity. Later, another scientist expanded our understanding of gravity even further. His name was Albert Einstein. Einstein proposed that gravity is not just a force. Instead, it is the bending of space and time. According to his theory, massive objects curve the space around them. Objects nearby simply follow that curved path. This idea is part of a theory known as general relativity. Black holes are one of the most extreme predictions of this theory. They form when very massive stars reach the end of their lives. Earlier, we talked about how large stars can explode in a supernova. After that explosion, the core of the star may collapse inward. If the remaining mass is extremely large, gravity continues pulling inward. The core becomes smaller, and denser. More and more matter is squeezed into a tiny space. Eventually, the gravity becomes so strong that nothing can escape. Not even light. At this point, a black hole is formed. A black hole has several important parts. The most well-known boundary is called the event horizon. The event horizon is the edge around a black hole. If something crosses this boundary, it cannot return. Not even light can escape beyond this point. From the outside, the event horizon appears completely dark. That is why we call it a black hole. But black holes are not cosmic vacuum cleaners. They do not roam the universe swallowing everything in sight. If the Sun were replaced by a black hole of the same mass, Earth would still orbit in the same path. The only difference would be the absence of sunlight. Black holes simply sit in space, their gravity influencing nearby objects. Sometimes, gas and dust drift close to a black hole. As this material falls inward, it begins to spin faster and faster. It forms a glowing disk around the black hole. This disk is called an accretion disk. The gas inside the accretion disk becomes extremely hot. It can glow brightly in X-rays and other forms of radiation. Ironically, even though black holes themselves are dark, the material around them can become some of the brightest objects in the universe. Some black holes are small, only a few times the mass of our Sun. Others are enormous. At the centers of many galaxies, scientists have discovered supermassive black hole. These giants can contain millions or even billions of times the mass of the Sun. At the center of our galaxy, the Milky Way, there is a supermassive black hole called Sagittarius A star. It sits quietly about 26,000 light-years from Earth. Most of the time, it remains calm. Stars orbit around it, slowly and steadily. For many years, black holes were only theoretical. Scientists believed they existed, but they had never been directly observed. That changed in 2019. Astronomers captured the first image of a black hole using a global network of telescopes. This project was called the Event Horizon Telescope Collaboration. The image showed a glowing ring of light surrounding a dark center. The dark region was the shadow of a black hole. It was one of the most remarkable images in modern astronomy. Even though black holes are powerful, They are also calm on cosmic timescales. They sit quietly in space for billions of years, slowly interacting with their surroundings. Stars may orbit them. Gas may fall into them. But much of the time, they simply exist. Silent. Invisible. Mysterious. Scientists continue studying black holes to understand more about the universe. They help us explore the nature of gravity, space, and time itself. But for tonight, we do not need to solve every mystery. It is enough to imagine the quiet presence of black holes in the universe. Massive, invisible, and patient. Waiting in the darkness between the stars. And as our slow lecture continues, we will move even farther across the universe, to explore the enormous structures that contain billions of stars. Galaxies. But for now, let your thoughts drift like distant starlight. Slow. Quiet. Weightless. Just like objects gently orbiting a distant black hole. In the calm silence of space. Now, we continue our slow journey through the universe. So far, we have talked about stars, planets, and black holes. But there is another idea that helps us understand space. Distance. Space is incredibly large. So large, that the distances between objects are difficult for the human mind to imagine. Here on Earth, we measure distance in meters, kilometers, or miles. For example, a city might be 10 kilometers away. Another country might be thousands of kilometers away. But in space, these units become too small. Even the distance between Earth and the Sun is enormous. That distance is about 150 million kilometers. Scientists call this distance 1 astronomical unit. It is often shortened to AU. 1 AU represents the average distance between Earth and the Sun. Astronomers use this measurement when describing distances inside the solar system. For example, the planet Earth orbits the Sun at about $1 Australian. The planet Mars orbits at about $1.50. The distant planet Neptune travels much farther away. Around $30 from the Sun. These distances already seem very large. But once we move beyond our solar system, the distances become even greater. So astronomers use another unit. The light year. A light year is the distance that light travels in 1 year. Light moves incredibly fast. About 300,000 kilometers every second. At that speed, light could travel around Earth more than 7 times in a single second. Even so, space is so vast that light still takes years to travel between stars. The closest star to Earth, after the Sun, is Proxima Centauri. Its light takes about 4.24 years to reach us. This means that when we see Proxima Centauri tonight, we are actually seeing it as it was more than 4 years ago. Light from distant objects takes time to travel. So when we look into space, we are also looking into the past. Some stars we see tonight sent their light hundreds of years ago. Some galaxies we observe through telescopes emitted their light millions, or even billions of years ago. Our galaxy, the Milky Way, is enormous. It stretches about 100,000 light-years across. That means if you traveled at the speed of light, it would take 100,000 years to cross from one side of the galaxy to the other. Inside this galaxy are hundreds of billions of stars, each separated by vast distances. Yet gravity gently holds them together, slowly orbiting around the center. Beyond the Milky Way, there are countless other galaxies. One of the closest large galaxies to us is Andromeda Galaxy. The light from Andromeda takes about 2.5 million years to reach Earth. When you look at Andromeda in the night sky, you are seeing light that began its journey before humans even existed in their modern form. This scale can feel overwhelming. But it is also peaceful. Because the universe moves slowly. Galaxies drift through space over billions of years. Stars orbit galactic centers over hundreds of millions of years. Even light, the fastest thing known, takes years to cross the distances between stars. Astronomers use powerful telescopes to measure these distances. Some telescopes observe visible light. Others observe radio waves, infrared light, or X-rays. One famous telescope that has helped explore the universe is the Hubble Space Telescope. Launched in 1990, it has captured breathtaking images of distant galaxies, nebulae, and stars. More recently, scientists launched an even more powerful observatory. The James Webb Space Telescope. This telescope can see extremely distant objects. Some of the galaxies it observes formed shortly after the Big Bang. In this way, telescopes become time machines. They allow us to see the universe as it existed billions of years ago, and yet, even with these powerful instruments, there are limits to what we can observe. The observable universe extends about 46 billion light-years in every direction. Beyond that, the universe may continue. Perhaps forever. But the light from those distant regions has not yet reached us. So we cannot see them. Still, the portion of the universe we can observe already contains trillions of galaxies. Each filled with billions of stars. Each separated by immense distances. Yet everything moves slowly, peacefully, and predictably. Just like planets orbiting the sun. Or stars orbiting the center of a galaxy. And as you listen to this quiet lecture, imagine the scale of the universe. Distances so vast that light itself needs years to travel. Galaxies separated by millions of light years. Stars quietly shining across enormous cosmic oceans. The universe is not rushed. It unfolds over billions of years. Slow. Calm. Patient. And just like the vast spaces between stars, your thoughts can become quiet tonight. Wide. Still. And peaceful. Now, we continue our calm journey through the universe. So far, we have talked about stars, planets, black holes, and the vast distances between them. But stars are rarely alone. Most stars exist in enormous groups called galaxies. A galaxy is a massive collection of stars, gas, dust, and dark matter, all held together by gravity. Inside a single galaxy, there may be millions, billions, or even trillions of stars. One of these galaxies is our home. It is called the Milky Way. The Milky Way is a vast spiral-shaped galaxy. It stretches about 100,000 light-years across. Inside it are hundreds of billions of stars. Our own star, the Sun, is just one of them. The Sun is located in one of the spiral arms of the galaxy. Far from the center. About 26,000 light-years away from the galactic core. At the center of the Milky Way, there is something very powerful. A supermassive black hole known as Sagittarius A star. This object contains millions of times the mass of our Sun. Stars slowly orbit around it, taking thousands of years to complete one orbit. Even our solar system is moving. The entire solar system travels around the center of the Milky Way. But the journey is extremely long. One full orbit around the galaxy takes about 225 million years. Scientists sometimes call this a galactic year. This means that since the dinosaurs lived on Earth, our solar system has completed only about one orbit around the galaxy. Galaxies themselves come in different shapes. Some are spiral galaxies. Others are elliptical, shaped more like smooth glowing spheres. Some galaxies have irregular shapes, without clear structure. The Milky Way is a spiral galaxy. Another famous spiral galaxy is the Andromeda Galaxy. Andromeda is the closest large galaxy to us. It is located about 2.5 million light-years away. Even though it is very far, it can sometimes be seen with the naked eye from dark locations. It appears as a faint, soft patch of light in the night sky. Astronomers believe that the Milky Way and Andromeda are slowly moving toward each other. But there is no need to worry. This event will not happen for about 4 billion years. When the galaxies finally meet, their stars will mostly pass by each other. Because the distances between stars are extremely large. Instead of a violent crash, the galaxies will slowly merge, forming a new, larger galaxy. Galaxies are not randomly scattered across the universe. They often exist in groups and clusters. Our galaxy is part of a small group called the local group. This group contains more than 50 galaxies. Most of them are small dwarf galaxies. But the two largest members are the Milky Way and Andromeda. Even larger collections exist, known as galaxy clusters. These clusters can contain hundreds or even thousands of galaxies. And clusters themselves can form enormous cosmic structures called superclusters. When astronomers map the universe on very large scales, they see something fascinating. Galaxies form long filaments and walls across space. Between these filaments are enormous empty regions called cosmic voids. This pattern is sometimes called the cosmic web. The universe, on its largest scales, resembles a vast web. Galaxies shining like tiny lights along enormous cosmic threads. All of this structure formed slowly over billions of years. Gravity gently pulling matter together. Small structures forming first. Astronomers believe that the Milky Way and Andromeda are slowly moving toward each other. But there is no need to worry. This event will not happen for about 4 billion years. When the galaxies finally meet, their stars will mostly pass by each other. Because the distances between stars are extremely large. Instead of a violent crash, the galaxies will slowly merge, forming a new, larger galaxy. Galaxies are not randomly scattered across the universe. They often exist in groups and clusters. Our galaxy is part of a small group called the local group. This group contains more than 50 galaxies. Most of them are small dwarf galaxies. But the two largest members are the Milky Way and Andromeda. Even larger collections exist, known as galaxy clusters. These clusters can contain hundreds or even thousands of galaxies. And clusters themselves can form enormous cosmic structures called superclusters. When astronomers map the universe on very large scales, they see something fascinating. Galaxies form long filaments and walls across space. Between these filaments are enormous empty regions called cosmic voids. This pattern is sometimes called the cosmic web. The universe, on its largest scales, resembles a vast web. Galaxies shining like tiny lights along enormous cosmic threads. All of this structure formed slowly over billions of years. Gravity gently pulling matter together. Small structures forming first. Then larger ones. Galaxies growing, merging, evolving. Inside galaxies, stars continue to form. Huge clouds of gas collapse to create new stars, while older stars quietly fade away. Galaxies are like cosmic cities of stars. Some regions glow brightly with newborn stars. Other regions contain ancient stars that have been shining for billions of years. When astronomers observe galaxies with powerful telescopes, they are also looking into the past. Because light takes time to travel. The light from Andromeda began its journey 2.5 million years ago. Light from more distant galaxies may have traveled billions of years before reaching Earth. This means telescopes allow us to see the history of the universe. One telescope that revealed many distant galaxies is the Hubble Space Telescope. In one famous observation, Hubble looked at a tiny empty region of space for many days. The result was astonishing. The image revealed thousands of galaxies in a single small patch of sky, each one containing billions of stars. And that tiny region was only a small part of the entire universe. This discovery helped scientists realize how vast the cosmos truly is. Trillions of galaxies may exist across the observable universe, each with its own stars. its own planets, its own cosmic history. And somewhere, around some distant star, there may be another quiet world, looking up at its own night sky, seeing galaxies far away, just like we do. And as you listen to this calm lecture, imagine drifting slowly through space, passing between galaxies, watching spiral arms rotate gently, seeing billions of stars glowing softly. The universe is enormous, but it moves slowly, peacefully, patiently, just like the quiet motion of galaxies across billions of years. Now, we slowly move toward a very deep question. What will happen to the universe, in the distant future? The universe has been evolving for billions of years. Stars are born. Stars grow older. Galaxies slowly move through space. And everything follows the quiet rules of physics. The story of the universe began about 13.8 billion years ago with an event known as the Big Bang. At that moment, space itself began expanding. Not an explosion in space, but an expansion of space itself. From that beginning, the universe grew larger and cooler. Matter slowly formed atoms. Atoms formed stars. Stars formed galaxies. And over billions of years, the cosmic structures we see today appeared. Even now, the universe continues expanding. Galaxies are slowly drifting farther apart. This discovery was first observed by the astronomer Edwin Hubble. He noticed that distant galaxies appear to be moving away from us. The farther away a galaxy is, the faster it seems to be receding. This discovery changed our understanding of the universe forever. But the story becomes even more interesting. In the late 1990s, scientists discovered that the expansion of the universe is not slowing down. Instead, it is accelerating. Something unknown is pushing galaxies apart faster and faster. Scientists call this mysterious force dark energy. Dark energy is one of the biggest mysteries in modern science. It appears to make up about 70% of the universe. Yet we still do not fully understand what it is. Because of this expansion, the future of the universe may follow several possible paths. One possibility is known as the heat death of the universe. In this scenario, the universe continues expanding forever. Over trillions of years, stars slowly burn out. New stars stop forming. Galaxies grow dark. The universe becomes colder and quieter. Eventually, only faint remnants remain. White dwarfs, neutron stars, black holes, and extremely cold particles drifting through space. This stage is sometimes called the dark era of the universe. Another possible future is called the Big Crunch. In this scenario, gravity eventually becomes strong enough to stop the expansion. The universe would slowly begin collapsing back inward. Galaxies would move closer together. Temperatures would rise. And eventually, everything would collapse into a dense state again. However, current observations suggest that the universe is more likely to continue expanding. There is also another extreme possibility, known as the Big Rip. If dark energy continues to grow stronger, the expansion of space could eventually become so powerful that galaxies are torn apart. Then solar systems. Then planets. And eventually even atoms. But if this scenario occurs, it would happen trillions of years in the future. Far beyond the lifetime of our sun. Speaking of our star, the sun still has about 5 billion years of life remaining. After that, it will expand into a red giant. Eventually, it will shed its outer layers and leave behind a white dwarf. But even after the sun fades, the universe will continue evolving. Other stars will shine. Other galaxies will slowly drift through space. The timescales involved are almost impossible to imagine. Millions of years. Billions of years. Trillions of years. From the perspective of the universe, Everything happens very slowly. Very calmly. Just like galaxies slowly rotating. Or stars quietly shining for billions of years. And that perspective can feel peaceful. Because the universe is not rushed. It unfolds gently, over immense spans of time. Stars are born. Stars fade away. Galaxies merge. Black holes grow. And the cosmos continues its quiet evolution. Even though the universe is vast. And filled with mysteries. It also follows simple physical laws. Gravity. Energy. Motion. Balance. These laws shape the structure of everything we see, from the smallest particles to the largest galaxy clusters. And as we come near the end of this slow science lecture, imagine drifting far beyond our galaxy. Seeing billions of galaxies scattered across the darkness. Each glowing softly. Each part of the same expanding universe. Moving slowly outward. In the quiet ocean of space. The future of the universe may be uncertain. But the journey of understanding it continues. Calm. Patient. And endlessly fascinating. Just like the stars quietly shining in the night sky, now, we reach the final part of our slow science lecture. Throughout this journey, we have explored many parts of the universe. We spoke about stars. Planets. Black holes. Galaxies. And the immense distances that separate them. But perhaps the most interesting thing about the universe is how quiet it really is. Space is often imagined as dramatic. Explosions, collisions, powerful forces. But most of the time, the universe is calm. Very calm. Between the stars, there are enormous regions of empty space. The nearest star to Earth, after the Sun, is Proxima Centauri. Its light travels more than 4 years before reaching our planet. Between these stars, there is mostly silence. Tiny particles of gas. A few drifting atoms. But mostly, empty space. Even inside galaxies, the distances between stars are enormous. Our solar system orbits quietly within the Milky Way. The galaxy contains hundreds of billions of stars. Yet the distance between most stars is several light years. This means stars almost never collide. They simply move slowly around the center of the galaxy. Each following its own path. Each shining softly in the darkness. At the center of our galaxy lies a powerful object. A supermassive black hole called Sagittarius A star. Even this enormous object spends most of its time quietly resting. Stars orbit it slowly, taking thousands of years to complete a single journey. Beyond our galaxy, the universe becomes even more peaceful. Galaxies drift through space, separated by millions of light years. One nearby example is the Andromeda Galaxy. Its light takes 2.5 million years to reach us. When you look at it tonight, you are seeing a message from the distant past. Across the observable universe, there may be trillions of galaxies. Each filled with stars. Each evolving slowly over billions of years. All of them moving outward as space continues expanding. This expansion began long ago. With the Big Bang. Since that moment, the universe has continued to grow larger. Galaxies drifting farther apart. Cosmic structures slowly changing. But all of this happens on enormous timescales. Billions of years. Trillions of years. From our human perspective, the universe appears almost perfectly still. When we look up at the night sky, the stars seem fixed. Quiet. Peaceful. They slowly move across the sky during the night. As Earth rotates. But beyond that gentle motion, everything feels calm. And that calmness can be comforting. Because it reminds us that the universe is not chaotic. It follows simple laws. Gravity pulls objects together. Motion carries them forward. Balance creates stable orbits. From the smallest atoms to the largest galaxy clusters, these same laws shape everything. The atoms inside your body were once formed in ancient stars. Long before Earth existed, those stars lived their lives, produced heavier elements, and eventually released them into space. From that cosmic material, new stars formed, new planets formed, and on one small planet, life appeared. So in a quiet way, every person on Earth carries a connection to the stars, not only through curiosity, but through the very atoms that make up our bodies. The universe is vast. Yet we are part of it. Tiny observers inside a much larger story. And tonight, as this calm lecture slowly comes to an end, you can imagine the universe continuing its quiet motion. Stars slowly burning their fuel. Planets orbiting their stars. Galaxies rotating gently. Black holes waiting silently in the darkness. Now, we slowly move toward a very deep question. What will happen to the universe, in the distant future? The universe has been evolving for billions of years. Stars are born. Stars grow older. Galaxies slowly move through space. And everything follows the quiet rules of physics. The story of the universe began about 13.8 billion years ago with an event known as the Big Bang. At that moment, space itself began expanding. Not an explosion in space, but an expansion of space itself. From that beginning, the universe grew larger and cooler. Matter slowly formed atoms. Atoms formed stars. Stars formed galaxies. And over billions of years, the cosmic structures we see today appeared. Even now, the universe continues expanding. Galaxies are slowly drifting farther apart. This discovery was first observed by the astronomer Edwin Hubble. He noticed that distant galaxies appear to be moving away from us. The farther away a galaxy is, the faster it seems to be receding. This discovery changed our understanding of the universe forever. But the story becomes even more interesting. In the late 1990s, scientists discovered that the expansion of the universe is not slowing down. Instead, it is accelerating. Something unknown is pushing galaxies apart faster and faster. Scientists call this mysterious force dark energy. Dark energy is one of the biggest mysteries in modern science. It appears to make up about 70% of the universe. Yet we still do not fully understand what it is. Because of this expansion, the future of the universe may follow several possible paths. One possibility is known as the heat death of the universe. In this scenario, the universe continues expanding forever. Over trillions of years, stars slowly burn out. New stars stop forming. Galaxies grow dark. The universe becomes colder and quieter. Eventually, only faint remnants remain. White dwarfs. Neutron stars. Black holes. And extremely cold particles drifting through space.